the p type of a material and n type of a semiconductor, and as well as the formation of p n junction diode. It is also called as a junction diode. In p type of a material, the majority charge carriers are holes. In n type of a semiconducting material, semiconductors, the electrons are the majority charge carriers. Means due to the charge carriers, the current conduction will be possible in that materials. So that here there is a some of the definitions we should learn about going to the forward discussion. The whenever the p-n junction diode is formed, due to the charge carriers of in both materials, the diffusion current will be flows. Due to the diffusion current at the junction, some of the layer is formed. Some of the layer is formed on both sides of the junction. That layer is called as a depletion layer. That layer is called as a depletion layer. That is here when these are all the holes and these are the electrons. Whenever this combined means p-n junction diode, this p-n junction diode, then the negative charge carriers will move towards the p region, and the positive charge carriers means holes move towards the n region. At the junction, some of the small thin layer is formed due to the diffusion of charge carriers. Small thin layer is formed. That layer is called a depletion layer, and its thickness will be in order of 10 to the power of minus 6 meters. 10 to the power of minus 6 meters. That's why the definition is, due to the diffusion of charge carriers, a thin layer formed on both sides of the junction. In this layer, charge carrier becomes static due to mutual attraction force between opposite charges. Here, this is the positive charge, this is the negative charge. Whenever they are moved this side and they are moved this side, then here in the depletion layer, due to this one is the positive and this one is the negative, then the negative charges will not allowed to pass through this, and positive charge carriers means holes do not pass over through this, across this will opposes. So that's why here the condition will be in static, both will be in pair, whole electron pair will be static condition. So that's why here in this layer, charge carriers becomes static due to the mutual attraction between the opposite charges. So that layer is called a depletion layer. So that's why the thickness will be 10 to the power of minus 6 meters. Due to the definition, in equilibriums, the opposite charge carriers accumulate at the junction. Opposite charge carriers accumulate at the junction, and for both sides of the junction. This produces electric field. This produces electric field. This electric field is called as a barrier electric field. Means this is the barrier. This is the barrier. So that's why the barrier electric field, due to the accumulation of the charge carriers both sides of the junction, electric field is produced. That electric field is a barrier electric field. So that this corresponds to the potential difference. Potential difference will be across the junction. Because of electric field is formed from this side, whole side to the electron side, moved this side, means a positive side to negative side. So electric field is formed here p side to the n side. So this corresponds that p, there is a potential difference across the junction. That potential difference is known as that potential barrier. That potential barrier. If the width is more increases, this potential barrier means this, if the depletion layer width increases, then potential difference also increases, then the potential barrier also increases. So that's why the potential difference across this, that V0 is equal to the ED, means electric field, potential electric field. So that's why it is for germanium. For germanium, that is 0.3 volts, and for silicon 0.7 volts. That potential barrier value will be 0.3 volts for the germanium and 0.7 volts for the silicon. So this is potential barrier. Potential barrier means, once again, in equilibrium, the opposite charges carriers accumulate. The opposite charge carriers accumulate on both sides of the junction, on both sides of the junction. This produces an electric field from P side to the N side. This is the P side and this is the N side. From P side to the N side means the whole side to the electron side. So that this corresponds potential difference across the junction is called. Potential difference across the junction is called potential barrier. It is denoted with V, and V naught is equal to the ED. ED means potential electric field. Then it is for germanium 0.3 volts and for silicon 0.7 volts. This is about potential barrier. By connecting this battery in such a ways, the depletion layer and potential barrier will be maybe decreases or increases. That can be PN junction diode can biased, means PN junction diode can be connected across the battery into such a ways. Then its a depletion layer thickness may be increases in such a way and also decreases. That is called biasing of junction diode. By connecting the junction diode to the battery in such a ways, in two ways, those are biasing the junction diode. Biasing the diode in two such a ways, their first one is the forward biased and second one is reversely biased. Let's see what is forward biased and what is reversely biased. So, forward biased, when biasing the PN junction diode into such a ways, biasing a junction diode means whenever by connecting the battery to the PN junction diode, then that is called as biasing the junction diode. That can be possible in two ways. Those are the forward biased and reverse biased. So first of all, we are going to discuss about forward biased. Forward biased means here the P type of a semiconducting material, the P side is connected to the positive terminal of the battery, and N side of the semiconducting material is connected to the negative side terminal of the battery. Means in a PN junction diode, this will be the PN junction diode, this is the P type of a material, and this is the N type of a material in PN junction. So this P type is connected to positive terminal of the battery and N type is connected to negative terminal of the battery. So that when by connecting this positive terminal and a negative terminal in such a way, this is called forwardly biased. That is, in forward bias, the positive terminal of the battery connected to P side and negative terminal of the battery connected to N side of a PN junction diode. So by connecting this, if the external electric field is produced by the battery, already without connection of the battery, there is an internal connection, internal electric field is formed. Already we know that is EI is moved inward direction of holes towards the N side, means P side to the N side. By connecting the battery in forwardly biased, the external electric field is applied across the PN junction diode, so that it exceeds the internal electric field. It means more electric field is formed more than the internal electric field. So that's why here this is the positive terminal. So here is the P type of material is also having the positive charges, positive charge carriers, that is holes. So due to the repulsion between the two positive charge carriers, that positive charge carriers move towards the potential barrier, that is depletion layer, means moves towards the in this direction. Due to the same repulsion between the negative charge carriers in the N type of a semiconductor material and N type of a material, N type of the N terminal of a battery, negative terminal of a battery, then due to the repulsion between both of them, this negative charge is also moved towards the in this direction, towards the depletion layer. So due to that repulsion force between the positive terminal and the positive charged holes and negative terminal and negative charged electrons, the depletion layer width will be decreases. Depletion layer width will be decreases. So that here a current set up across the junction diode due to the diffusion charges. Diffusion charges means the electrons move towards this direction, positive charges holes moves towards N type of a material. So that here the diffusion of charges, the current will be flows through the diode. Then the results, the depletion layer width decreases, so that the potential barrier is also, the thickness of the depletion layer decreases, and current, the negative charge particles move towards this direction and moves towards the positive terminal, and these positive holes move towards the, in this direction, passes the current through the diode and moves in this direction. So that's why here if we draw a graph between the current and voltage, then potential, then the graph will be like this. At initial stage there is no much of increment of the current voltage, so that goes on, the current will be increases because of the thickness of the depletion layer decreases. Until the decrement of the depletion layer, the current will be flows normally. After the charge carriers, whenever we diffusion of this charge carriers, the depletion layer width goes on decreasing, and furtherly the current flows through the diode more and more. So that the maybe the depletion layer width will be total decreases at the time, at some time, that will behaves like that there is no any depletion layer, like that. So here we can say that whenever the charge carriers are moving across the junction diode slowly, diffusing from their region to the another region, then goes on increasing the jumping, means it goes on increasing the diffusion, then the thickness will be less, decreases, and goes on that, then the total depletion layer width totally decreases, and in some time it can be considered as there is no any depletion layer, means the potential difference will becomes zero. The total holes acquired by the electrons, so that's why I have moves in this direction, electrons will move towards the direction, the current flows in the total direction, when finally at the peak stage the current will be more and more, so that due to the forward bias the current will be flows in the circuit. So we can say that the graph is not linear, so that's why we can say that if the depth d is equal to, means the thickness of the depletion layer d1 can be considered as this. If the d1 thickness of it decreases, then the potential V is equal to E into d1, means the depends on the potential difference, depends on the thickness of the depletion layer and the electric field which is applied and the internal electric field. So that's why some of the important points. In that, the forward current of the in order of milliamperes, means whenever that forward current will move in the milliamperes, and that the current flows due to the both charges, means due to the negative charge particles move this side, and positive charge carriers will move this side. So due to the both charge carriers, current will be flows in the circuit, and also the variation of current is not proportional to V, means the V is not proportional to I in this case. So that's why here we can say that the graph is not linear. Linear means it is not move straightly, means it is not linear. This will be like in a Karupa. This is the forward bias. Say about once again, when battery is the positive terminal of the battery is connected to the p side of a material, and a negative terminal of the battery is connected to the p-n type of a semiconducting material, then it will be the forwardly biased. PN junction diode is forwardly biased when the positive terminal of the battery connected to the p side of a material, and the negative terminal of the battery is connected to the n side of a material, then the external electric field is applied to the PN junction diode, so that it is more than the internal electric field. So that the way here, the due to the repulsion between the positive terminal of the battery to the positive charge holes to the majority charge carriers which are placed in the p type of a material move towards the potential barrier. Due to the same repulsion between the negative terminal of the battery and the n type of a materials, then electrons moves towards the potential barrier, so that the potential barrier thickness will be decreases, so that the current will be set up across the junction diode due to the diffusion of charges. This one, the thickness of the depletion layer will be decreases, and as well as here the potential difference will be decreased, means the potential barrier is also decreases. If we consider D is the thickness of the depletion layer, then the potential V is equal to EI, means internal electric field into D1 is the thickness. This will be the potential, we can find it out. So that's why here in this case of forward current is in a milliamperes. Forward current is passed through the current is milliamperes, and current flows due to the two mobile charge carriers. These are the electrons and holes. Both of the majority charge carriers, current will be flows through the circuit, and as well as in this the current is not proportional to the potential, so that why the graph is not linear. Whenever we plot the graph between the I and V, means current and potential, the graph is not linear. This is about forward biased.